Thank you very much.
Thank you very much.
Oh, that's nice. I've got a bit of echo. That's gone. Excellent. So welcome all, and welcome in particular to those who might have been waiting to find out more about Mojaloop and ISO 20022 following our reference architecture meeting earlier today. So the purpose of this, Adrian and I will be co-presenting, and the things we're going to be talking about are, first of all, mapping ISO messages onto Mojaloop endpoints. We've done some work on this, and we have actually tried it out in the real, as we will be explaining in the next topic, where we'll be talking about the BIS Innovation Hub and Swift jointly ran a hackathon on innovative uses for ISO 20022, which our Mojaloop team entered, and which we were fortunate enough to be co-winners of. So Adrian will be talking a bit about that. Next, we want to talk about a real implementation of an ISO 20022 version of Mojaloop. We have a request currently outstanding for someone who wants to implement a national payment system which uses the Mojaloop switch, but uses ISO 20022 messages. So we'll be talking a bit about how we plan to do that. Then we'll be talking about our plans for the next PI, specifically a detailed position on PISP, because it's not clear, at least it's not clear to me, how ISO 20022, or in what sense ISO 20022 intends to support PISP interactions. Second, a working ISO version of Mojaloop for the real implementation that we just talked about. And third, a business and sales case for the how can I put this, the marriage between Mojaloop and ISO 20022, assuming, that is, we get rid of all of the objections that the parents currently have to this message. We think it's true love, but you never know. The course, as they say, never did run smooth. So, short introduction. Question, sorry, I'm confused at this point. Ah, yes, okay, let's get going. So what then is ISO 20022? It's a standard for electronic data exchange between financial institutions, and as Miller might have mentioned already, that essentially means banks. It describes a data repository containing descriptions of messages, definitions of message content, and business processes, and together with a maintenance process for the repository content. It covers a wide range of stuff, some things that we are interested in from the real-time regional payments context, others that we're not quite so interested in, such as securities trading, credit and debit card transactions, at least at the moment, and those sorts of things. So it's important to remember that ISO covers a very wide landscape, and it's only a small subsection of that landscape that we are wanting to use for a real-time retail payment system, at least for the moment. So let's start then by looking at how we map ISO 20022 messages onto the Mojaloop orchestration. Now, I hope it won't be a surprise to people at this meeting, the idea that one of the fundamental points of Mojaloop is the orchestration of transfers that it does. And in particular, the three phases of a transfer. In the first phase, we identify the account holder for the account we want to pay. So one of the things that we say in Mojaloop is you shouldn't need to know who owns an account, a merchant's account or whatever, in order to pay that merchant's bill. You just need to know something about the merchant. It might be a merchant ID, it might be a phone number for a small merchant, some kind of identifier, but you shouldn't need to know who owns the account. In the second phase, we set the terms of the transaction, and the payer DFSP will say, I want to transfer this amount of money. The second important point to remember is that In our model, it's the payee DFSP who says what the eventual terms of the transfer will be. In most models, and that really includes most implementations of ISO 20022, it's the payer institution that says, I propose to make this transfer. And in ISO, the payee institution can say, no thanks, or it can accept the transfer. In our model, it's the other way round. It's the payee institution who says, these are the terms under which I'm prepared to accept the transfer. And the payer institution has the choice of either saying, yeah, okay, I accept it, or alternatively, no, I'm not having that. I won't send the transfer. And in particular, there are two reasons for that. First of all, it's going to be the payee DFSP who takes a financial risk, because we say a payment in our system must be cleared to the customer straight away. So that means that in a lot of settlement models, the payee DFSP will have committed funds, given them to its customer before it's actually got those funds from the sending institution. So in our system, it's the payee institution that assumes the risk, and therefore, in our view, it's fair for them to say, yeah, this is how I'm going to do it. Second, we say as one of our founding principles that we shouldn't take any money from our customer, the payer that is, unless they are completely clear how much is going to be taken. And it's only when the terms of the transfer are finally set that the payer DFSP can go back to its customer and say, this is how much it's going to cost you to make this transfer. Are you prepared to accept it? So those two reasons, again, that's because ISO 20022 doesn't include orchestration in that sense. It doesn't include any statements about what might happen outside the actual content of the message. It's perfectly possible to imagine that a bank will just go ahead and make a transfer. We don't support that. And then finally, we make the transfer. We send the funds to the switch where they are reserved, so that the payee institution can be confident that the payer institution will always have sufficient funds available to settle the transfer. It's passed through to the payee DFSP, who will take the who will commit the amount to the customer, provided they're satisfied, and send back a message that says, yep, I've cleared the funds to my customer, you can go ahead and commit them. The switch will commit them, and it then sends them back to the payer. It sends the message back to the payer institution, which will finally commit the debit from its customer's account. So that's the way we do things, and that just emphasizes that. So we have 6 messages that we need to think about. First of all, we ask for information about the payee, and the Mojaloop way of doing that is via a get parties request. Second, the payee institution will return information about the account that's associated with an identifier, and that's the Mojaloop put parties request. Then we propose a transfer, which is post quotes in Mojaloop world. We confirm the terms of a transfer, which is put quotes. We action the transfer, and we confirm the result. Now, the proposed ISO 20022 equivalents for these are, there's a get account message, which asks for information about the pay. Now, strictly speaking, using the endpoints currently in the in the Mojaloop model, we wouldn't necessarily need to do that, because we ask for information using a get parties, and the get parties has no message body. So in principle, at least, we could send a message that just said get party in the same way as we do now. However, it's possible that you may want to do this explicitly using a message. And if we did, the CAMT 003 get account message, we think is the one that should be used. This has a parallel message, return message, which is a CAMT 004, which returns information about the account, and in particular, of course, whether the account was actually found or not. So that's the first pair of messages. Second, we look at proposing a transfer, which is the Mojaloop post quotes. Now, I'm not going to make the pain joke, but ISO 20022 has a set of messages which are about payment initiation, PAIN. And pain.001 is the message that initiates a credit transfer. So it's used to request movement of funds from the debtor account to the creditor. These little definitions in italics, are, by the way, are from the ISO 20022 dictionary definitions. Returning the information, there is a PAIN 013, which is an activation request. And this is equivalent to saying, please action a payment with these terms. It's equivalent almost to our request to pay, but we think it maps well onto the semantics of the put quotes, which basically says, here are the terms under which I will accept the transfer, you may go ahead with it. This is a relatively new message, by the way, and it's not wholly aligned with the way in which the other messages work. In particular, for instance, the PAIN 013 doesn't accept multiple creditors, which all of the other messages we're going to be talking about do. So there's some little alignment to be done there, but in principle, at least for our purposes at the moment, it will work fine, we think. Then, initiating a transfer, there is a credit transfer set of messages, PACS, and PAX 008 says basically execute a customer credit transfer between two financial institutions. So this is sent by the debtor agent to the creditor agent, and it says, please do something now. So that's the difference between the PAIN 001 and the PAX 008, at least in our world. And then finally, there's a PAX 002, which is a status report about the payment. And that obviously corresponds to the put transfers that we have in the Mojaloop API at the moment. So, broadly speaking, we think we can retain the existing orchestration of a Mojaloop transfer. There's a discovery request, a discovery response, an agreement request and response, and a transfer request and response. We think we can map an existing ISO 20022 message onto each phase of the transfer like that. So, sounds good. There are, however, some drawbacks on this, some of which came up while we were doing the hackathon, others of which we thought about before. In particular, there are identifier mismatches now, as I'm sure you all know because you've done your API homework. We use UUIDs, unique identifiers, to identify requests, to identify messages of all kinds. That's just our standard way of doing it. Unfortunately, although ISO has identifiers, it uses 35-character strings, which are 1 character too short to hold our identifiers. So what we did on the hackathon was we changed the data type for these identifiers to be a UUID, which it's an existing ISO data type. It's just not the one that's used for identifiers. So we will need to do some work on that in order to make sure that we can be properly aligned. The second and more interesting one is the question of cryptographic signatures. Now, as you will doubtless know, we use cryptographic signatures to allow all parties to be confident that a transfer has in fact been approved by the payee and that the switch should record that it has completed successfully in its ledgers. Now, ISO has no concept of these signatures. It doesn't have anything like that. So there are essentially 2 ways in which we could approach this. The first way is that all ISO messages have a kind of extension area at the bottom of the message that can be used with ISO approval to add new types of information that are required for particular purposes, but which may not be sufficiently generalized to merit incorporation into the ISO standard itself. That's a way of doing things, but actually we think we will want to do it for every scheme, not unnaturally, that uses ISO and Mojaloop. And therefore we will look, we think, to request a modification to schemas to include the ability to have a cryptographic signature attached to a message in the same way as we do in the FSP IOP API that we have at the moment. That's the approach we took in the hackathon. Nobody squeaked too hard about it. So we are reasonably optimistic that we will be able to do something in that area. So those are the drawbacks. There are some other drawbacks. So there are some ways in which ISO represents things in ways which are different from the way in which we represent things. In particular, for instance, we have quite a complicated method for identifying the use case for a particular transfer. Now, ISO doesn't have anything that corresponds with that. However, it does have a way of saying this is the use case, but it's simply an enumeration. So we'll have to make some changes and some mappings there. Another example, as I think I mentioned earlier on, is the situation where we have a single identifier type and identifier value structure that we use for all types of identifier, whereas in ISO, different types of identifier are scattered across different locations. Sorry, when I say scattered across, that sounds impertinent, doesn't it? But they are distributed across various parts of the message. So they are not simply there and available in the obvious way. Now, that probably doesn't matter to banks because they don't think like that. Oh, sorry, they already think like that. It might be much more difficult for other types of participants in the scheme who may not have the advantages of being a bank and therefore may find it more difficult to identify these sorts of things. However, we pen that discussion for the moment. Okay, so the next thing we want to think about is how can we extend the system from a simple transfer? Now, we definitely currently do merchant request to pay. Fortunately, as I said before, the pane 013 message, the one that we're proposing to return from the payee DFSP saying, yes, please go ahead with this transfer, is, we think, essentially equivalent to a request to pay. And we think that it would therefore be possible to use that as a way of doing request to pay. So we are kind of okay about that. The question of bulk is actually much easier in ISO because the existing messages allow the definition of multiple recipients. So we can use the existing messages. There will no longer be any need for specific bulk endpoints, though we could support them, but using the same message structures. The only exception to that, as I think I said before, is that the pane 013 doesn't allow multiple creditors, whereas all the other things do. But I'm hoping that that's just a temporary glitch. Okay, so there's that. Now, PISP is a bit more difficult. Initiating payments via a PISP, for which we use request to pay, is relatively simple in the ISO world, as we've already said. But there are issues around requesting authorization in ISO messages, which is something that we do at the moment, and we certainly want to do for a PISP, as I'm sure you will have gathered from Lewis's expert presentation earlier today. And the other question is about PISP registration, and particularly how accounts are linked together between PISPs and account holders. There is some thinking on this, but it's not clear, or at least not clear to me, how closely this maps onto the thinking that we've been doing about PISP. So I think there's some effort and work that needs to be done in that area, pardon me, to make sure that we have a good answer in the PISP world, because I think we're all agreed that one of the big focus points for Mojaloop is going to be its really world-class support for PISPs. And not to be able to provide that in an ISO 20022 world would, I think, be a considerable drawback. So to summarize, I think we've been reasonably successful in proposing a way in which the ISO message structures could be mapped onto the Mojaloop transfer orchestration processes, and how we could extend it to provide nearly all of the functionality that we currently provide. As I say, there's a bit of work to do, but in principle, it seems to be relatively successful, I think. We've reviewed this with the South African Development Corporation people who've been working in a similar area. They are, I think, reasonably happy with it as a plan. But of course, we are always happy to receive comments, constructive criticism, actually destructive criticism. We don't care. We're grown up. So we're always happy to engage in further discussion about this. Now, that's all I have to say on that topic. Does anyone want to, should I pause for questions at this point, or should we move right along?
Let's see if there's any specific questions on the mapping before we
okay.
do. So far in the comments on Zoom, it's mostly been discussion around signature formats, which I think is yeah, we're in the weeds already. We'll figure that stuff out.
Mm-hmm.
Any other thoughts on the mappings, these additional use cases?
I don't think so at the moment. I mean, as I say, we are fortunately, as you will be seeing quite soon, going to be in a position to test this thinking out quite soon. But for the moment, I mean, certainly we found that for the hackathon, things went relatively well. There were the kind of all of the little glitches that you would expect when you actually try and implement something like this. But broadly speaking, I think we managed to get the stuff that we wanted to organize. I think the things that we will need to think about in particular are that those of you who've looked at ISO messages will see that they are very extensive, or potentially very extensive. We will have to do some detailed thinking for individual schemes about how we propose those other fields should be usable in schemes. Now, I've certainly seen some cases where people implementing schemes using ISO messages have said, you can use this information, additional information, to communicate with each other, but we will not take any notice of it, we the switch, that is. And I suspect that's going to be the kind of area where we will end up. So what we will do is not want, as far as possible, to unduly restrict how people use the extensive syntax of an ISO message to pass information back and forth between each other. But we will want to say that there are these things which the internal workings of the switch must have present in order to work properly. Fortunately, they are mostly things which are already required to be present, so that's not too much of a problem.
Yep.
So, if no one has any more to add on that context,
Michael,
I will pass across. Oh, sorry.
Yeah, there's Lewis.
Hi guys.
Lewis.
Yeah, it's Lewis here. Just more on the PISP registration. Surely we're not the first people solving this problem.
No, we're not. But
I'm not sure.
Sorry, carry on.
Yeah. I'm just wondering, yeah, is there other templates that we can use, or is it a case of finding like the closest matching looking ISO message and ramming whatever we need to ram into?
PISP supported at the center is kind of unusual, actually.
Okay.
So
sure.
it's a unique proposition that we're offering. UPI is the sort of the example everyone looks at, but in other PISP architectures, generally you're expecting the PISP to integrate directly into the ASPSP, or in our world, the DFSP. So and those are
Yeah.
often not ISO 222. Those are, you know, more traditional REST APIs and things like that.
Yeah,
That's your
that's
open
the
banking.
UK model, right?
So yes,
UK,
that's right. There
Europe.
are some, there are some ISO messages that support that, but as Adrian says, they assume the existence of an external registration authority which is managing all of that. We've gone, as Adrian says, down a different route, which says it will all be internal to our process, and that essentially means that ISO can treat all of that stuff as being out of band. Something it doesn't have to worry about. So that's the reason why I say we will need to have a think about how we plan to support that.
Okay, thanks for that.
Okay. Sorry, I'm just want to say Leslie Ann's done a question about correlations. Yes, we are thinking about correlation IDs, and generally speaking, we think that's okay. The stuff that isn't okay in the message itself can be supported, we think, by the use of rules, scheme rules, I mean. So we think that bit is covered, but how often have we thought that in the past? Okay, so let me then move along and pass the baton to my illustrious colleague, Hope Bailey, to talk about the hackathon.
The hackathon. So if we have a video which we're going to leave till the end to avoid lots of back and forth with screen sharing. So we'll save it's 4 minutes, actually 4 minutes 15, even though we were supposed to make it 4 minutes. That we'll show you at the end. But just to give you a background, there was a hackathon arranged by the Bank for International Settlements a few weeks back, probably a bit longer than that now. As you see on the slide, the purpose of the hackathon was a collaboration between the BIS and SWIFT to encourage people to think about how they would use ISO 222 messaging, specifically in cross-border use cases. So I think that is well understood to be a pain point. So anyone who's been involved in some of our cross-network, cross-border discussions may think that we're alone in the world in finding that a challenge. We're not, so we can feel comfort in that fact. And there's a common there's a structure within the ISO 222 community called a common market practice, where based ISO 222 is seen as the standard, but the common market practice is sort of a refinement of that standard or specialization for specific use cases. And there's quite a lot of work at the moment on common market practice for cross-border. In any case, this hackathon was hosted over the course of a week. You can go on to the next slide. Thanks, Michael. And there were actually two teams from the community that entered the hackathon. I'm happy to see Istvan is on here as well. So Istvan and the MyFOS team also made a submission. And then Motorsbox, Quill, Crosslake, there was a bit of a cross-functional team who were haphazardly assembled by Michael via Slack. I think anyone who was foolish enough to put their hand up got grabbed and delegated work to do.
And even some who weren't.
And even some who weren't. And there were 60 entrants, I believe. And we were fortunate enough to be in the top 3. So we were featured as part of the BIS Innovation Summit the following week. What it involved was spending a week developing a working prototype. I think that was quite unique with our entry. In the end, what was submitted was actually either a video or a presentation. We submitted a video and a presentation and a working demo. So we're just overachievers, what can I say? So I want to say, yeah, big congrats to everyone who put a lot of work into this. I'm going to leave someone out if I try and name everyone. Miguel, Don, VJ, Michael, Sam, Leslie Ann. Have I left anyone out? Damn, I probably have. And anyhow, I think what was great about about our solution and the fact that it was picked. There was a lot of fantastic exposure for Mojaloop, what we're doing. We really highlighted how Mojaloop provides a last mile link in a multi-hop, cross-border transaction. And our use case emphasized connecting sort of payment systems in more developed economies into economies where Mojaloop is more likely to be deployed, sort of developing economies, and that focus on connecting, the poor into the more developed financial system. So I thought that was great. Another important part of our submission, which you'll see in the video, was highlighting the use of the interledger protocol. And I thought it really helped emphasize why we do it. I think often newcomers to the Mojaloop community don't really understand the condition and fulfillment idea. And it really, for a cross-network transaction where you have the singular condition and fulfillment that travels the full length of the transfer, and the sending institution can have this certainty around real-time delivery on the receiving side, even though they're not on the same network or in the same scheme. I thought it was a fantastic way to demonstrate that. And most importantly, it gave us an opportunity to really test out what we thought we knew about ISO 222, have some experienced people to listen to that gave presentations on extending it, that talked about how it's being used. And subsequent to the hackathon, Michael and I have chatted with Istvan and understand a bit more about their submission, and incorporated some of what they're doing into our thinking for Mojaloop in general. So all in, ticked a lot of boxes, both in terms of learnings for the community, exposure for Mojaloop, and helping us to develop our own ideas internally. One more slide, Michael. It's actually an animated slide, which I'm going to talk through and take credit for.
Yeah.
This is actually Michael's slide. So this is the use case that we demonstrated. As you can see, top left, you have Amanda, who is a Lake City Bank customer, and she wants to send money to her aunt Honorine in Rwanda, who has a Rwanda Pay account or wallet. And what we introduced is a fictitious service that doesn't exist today, but one that I think is going to be an essential part in the long term of cross-border mobile money, is a global address lookup service. So the Lake City Bank will take Aunt Honorine's internationally unique, universally unique Mizden, look up how she is able, how money is able to be sent to her, and get a response back from there. And then some ISO 222 based network would then be used for the next step. And we weren't specific that it was Swift. It could be a European network. Specifically, it could be anything. But the idea here is demonstrating the 222 mapping and transition at the Equity Bank in Rwanda. So what Equity Bank in Rwanda are receiving are ISO 222 messages, but they're also participants in a Mojaloop system. And so they forward on FSP IOP messages through the Mojaloop hub. So the first message they will receive is the account lookup. They'll pass that on to Rwanda Pay to verify that Aunt Honorine's account is held there. And there'll be a quote and a transfer exactly as we would in our normal Mojaloop system. And each time it's an ISO message exchange between Lake City Bank and Equity Bank, and an FSP IOP message exchange between Equity Bank and Rwanda Pay. Worth pointing out here that this is not the heterogeneous messaging concept that was discussed earlier. This is message translation happening at Equity Bank in Rwanda. In this case, Mojaloop is speaking FSP IOP to its participants. So that's the solution. And I think I won't go into too much more detail. The video does that later on, and we've got a bit to get through. So Michael, I'll hand it back to you.
Thanks very much. Just a couple of things I'd like to add to this excellent characterization. First of all, one of the things that the ILP solution enabled us to do is, you will notice that in this structure, the Lake City Bank doesn't need to know anything about Rwanda Pay, even that it's there. it thinks it's talking to Equity Bank Rwanda. Now, what the ILP packet means what the ILP structure means is that even though it has no idea who eventually approved that payment, it can still be confident that the payment was actually cleared to the customer's account because of the match between the fulfillment and the condition. So that's an important, I think, characteristic of this solution that it's worth emphasizing. The other point, as I said, is that the global address lookup service means that the sending bank, the Lake City Bank, needs to know which ISO 20022 bank to apply to route a message, to route a payment to a recipient, to the owner of an identifier. So that means that we need some kind of central service, basically, that when you say, here is the phone number, you get the answer, talk to Equity Bank Rwanda. You don't, as an ISO 20022 bank, get the answer, talk to Rwanda Pay, because you don't know how to do that. And in our solution, you don't need to. So those are the main characteristics of the solution. Okay. Oh, so the other thing I wanted to say is that one of the other things as a consequence is that we will be interviewed, we, the winning team that is, will be interviewed for a presentation at CyBOS this autumn. So they will be looking for consequences, shall we say, of the extraordinary performance that our developers put up as part of this. I mean, you're listening to Adrian and me talk, but actually, it's not us who really put all the work in. It's the developers whom we should be
sorry, Michael,
thanking and congratulating.
You broke up a minute there. I didn't hear who the presentation was for with the winning team.
CyBOS. Sorry, it's for CyBOS this autumn.
Oh, awesome. Wow, congratulations to everybody. That's, I think if I read Sam's message correctly, that would be Lewis, Michael, Adrian, Don, Miguel, VJ, Leslie Ann, Sam, or Warren, maybe. A little Warren.
Yeah, that's right.
There's some Warren in
there. If he buys us enough drinks.
That's awesome, guys. Fantastic.
Okay, so as Adrian says, we've got many fish to fry, so we're going to fry a few more. So we are in the fortunate position of having a real implementation to play with, to satisfy. What's the requirement here? It's a national payment switch in the early phases of live operation. It's already using ISO 20022 messaging for P2P transfers. And the intention is that we will change the core switch technology to Mojaloop. And that is at least partly so that we can extend the use cases to at least merchant payments, which will include QR codes. We'll be talking a bit about this later on this afternoon. Bulk payments, including government disbursements, and PISP. Particularly merchant payments and bulk payments, we will be expecting to do quite quickly. So the existing system then uses the following endpoints. It uses CAMT 003 and 004 to do account lookups, which is good. It uses PAX 008 and PAX 002 to do a credit transfer, which is also good. But you'll notice that it doesn't currently have an agreement phase. We'll talk about how we might address that in a little bit. So the discovery service uses a central data store at present to resolve DFSPs and also to return the additional information, particularly to do name discovery and things like that. Now, as I'm sure you know, the Mojaloop way of doing these things is to allow the participant themselves, the payer institutions, the payee institutions, to return information about their account. We think that's more efficient in terms of information processing, because it means that the switch doesn't have to have separate copies of information that the payee institutions already have. And it also means that you can be sure that you're always getting the most up-to-date information. However, they have decided not to do it in that way. The central store is maintained by the DFSPs themselves using analogs to the Mojaloop participants endpoint. So that's not too much of a problem. We can include that relatively simply. So when we look at the schematic of an account lookup, it's kind of like the following. The payer DFSP will send a message to payment manager, which will send a message to the Mojaloop switch, to the lookup service, which will do the lookup on, it will always look up in the same identity registry, which will essentially be the oracle that they already have. Check the existence of the key, build a response message, send the CAMP 004 message back, and that will go straight back to the questioner. It won't, and indeed can't, go to the payee DFSP, because at the moment, payee DFSPs in this scheme don't expect to receive identification requests. So that will work not exactly the way in which things work now in Mojaloop, but it's kind of reasonably close. So, as I say, we are assured and we're reasonably confident that the registry oracle does have all of the information that will be returned, though we might have to add a little bit to that based on what we talk about with compliance later on this afternoon. And the message, as we said, has the requester as the destination. In traditional Mojaloop, it'll have the payee DFSP as the destination. So, executing a transfer. As we've said, there's no agreement phase. So the plan at the moment is that we will simulate the agreement phase using the magnificence that is Payment Manager. And I'll talk a little bit now about how that would work. So here's the schematic of a P2P transfer in the demonstration phase. You'll see that there will be a slight difference how we actually plan to implement this in production. So we send a message, or the payer DFSP sends a message, which is a PAX 008 message. Please make a payment. The payment manager converts that message into a post quotes message, and the switch transfers the post quotes message to the payee DFSP's payment manager. That issues a put quotes message because in the current scheme, there is no space for anything other than a simple response. The quote is stored at the switch and the response goes back to the payer's payment manager. The payer's payment manager then generates a post transfers message based on the put quotes message. This is still essentially the same content as the PAX 008 message, sends it to the switch, which reserves the funds, sends the post transfers message to the payee's payment manager, which converts it to the original PAX 008 and sends it to the payee DFSP. The payee DFSP is happy with the idea that it's going to receive a PAX 008, which means make a payment. It will decide to respond positively and it sends back a PAX 002. The payee's payment manager converts that into a put transfers message with a fulfillment attached. The switch commits the funds, sends the put transfers message to the payer's payment manager, which converts that into a PAX 002 message and sends it to the payer DFSP, which gets what it was expecting to get. So it will now make its peace with the customer and everything will be fine. So that's how we plan to do things in demonstration. We can do that relatively simply because we don't have to make any changes to the switch in order to do that. All we need to do is to configure the two payment managers correctly. So that will enable us to get things going quickly and to demonstrate how this would work in a very simple way. When we look at how we will do this eventually in production, there are some slight changes. Now, the payment manager will just send the PAX 008 through. It goes to the payee's payment manager, which adds a condition, sends the PAX 008 plus condition back to the switch, which stores the quote, and back to the payer payment manager. It then goes to the payment manager, sorry, the payer's payment manager then sends back PAX 008 plus condition, which is now interpreted as a please reserve funds. The message goes on to the payee's payment manager, which removes the condition and sends the PAX 008 through to the payee DFSP. The payee DFSP generates a PAX 002, an acknowledgement. Its payment manager adds a fulfillment to it. The message with fulfillment goes back to the switch, which looks at it and says, okay, I recognize this, it's good, commits the funds, sends that to the payer payment manager, which removes the fulfillment, and then sends the PAX 002 minus fulfillment in its naked state back to the payer DFSP. So again, everybody gets what they're expecting to see in terms of participants, pardon me, but now the switch is actually working with real ISO messages in the new format. So that's how we propose that should happen. Sorry, I've got all this nicely automated. So yes, I'll just go through this again. The payment manager does a simple pass-through. The ML adapter knows this is a quote because it's a PAX 008 with no condition. It forwards it. Again, the payment manager knows this is a quote. It adds a condition. And there we go. So what's our conclusion? First of all, we can support a broad range of Mojaloop use cases using ISO 20022 messages with relatively small changes. Second, this is going to be native support. The switch is going to process messages in ISO 20022 format. We will map ISO messages onto the existing endpoints. We will specify the ISO 20022 data items that are required in order to use a given message in Mojaloop, but we won't constrain the use of other ISO 20022 data items for participants to communicate with each other. And as we've said already, there are some areas where further analysis is required. Let me just pick up Lewis's question. How do we do non-repudiation with these types of messages? Now, Lewis, I want you to pay careful attention to this hat I'm holding in my hands because it's got a rabbit in it. And the rabbit says, Padoin, at the moment, payment manager manages all of the signing of messages for non-repudiation internally. So it adds that stuff already. And that stuff goes in the header of the message. So everything's fine.
And
Lovely.
with all due respect to Deus Ex Machina, I would have said that there are still some cases we need to spell out a little bit more. There's two areas, I think. One is somewhat obvious, that the negative cases like timeouts need to be structured in a way that at least the payment managers on both sides can dot and cross those messages off. But I would have said that it's more than that, given that in a ISO environment, a credit push message reservation occurs before the actual pay message is emitted. And that in our environment, it's not. In our environment, we don't actually see the reservation of customer funds until the prepared message is submitted, which is at the second stage, or the third stage, I guess, the transfer stage. And so it's knitting those together in a way to make sure that they make financial sense and that we're getting to a level of scheme protection that the scheme would want to encode in its rules. Given that it's using ISO on one side, presumably on both sides in some cases here, is an important part of this. So I get maybe bringing in that the retail accounting side of this thing would be somewhat helpful to think through, in addition to the negative cases.
I confess, Miller, I got rather carried away by things, and you're absolutely right. There's going to be a considerable amount of work to be done to make sure that this isn't watertight. But my point was, I suppose, to say that in the great tradition of scientific discovery, although you're pretending to be deductive, you're actually being inductive. We know where we want to get to.
Indeed. I guess abduction itself can be testing the end hypothesis, but it can also be used to structure that hypothesis in the beginning. And I'm of that mode. Yeah. Very nice. This is excellent. I mean, it's really great to see a complete mapping all the way through. But this is the new learning for me from this. I thought was quite remarkable is this notion of using the payment manager to essentially hide the details. At first, it feels like it's a bit of that Deus Ex Machina, but it's not really, because banks do this already. They put front end switches in all the time to talk to retail networks like ATMs and point of sale and Visa and MasterCard and so forth. This is always done with front ending, whereas the core bank itself is the thing that's structured on the back end. And so figuring out the way to look at what their assumptions are about what these front end switches are capable of within their own infrastructure, modeling payment manager to be a good role taker there is a way perhaps to get to success. And then looking at the way, of course, you have to map the end-to-end into ledger payment condition and fulfillment all the way through, so that two payment managers at least can agree and reconcile against the core banking actions. But those are somewhat separate activities. They're important, and I don't want to downplay them. But this is the first time I've seen a completely worked through example. It's awesome.
Yeah, we're also so from the coil side, we're working with the Motorbox guys on adding the work we did with 8583 as well into Payment Manager, which is being open sourced. So just so we're clear, that's going to be a sort of an OSS contribution. So we wrote what we call the legacy payment switch adapter. Right now we're focusing on if you have a DFSP or a bank, or well, let's call it a participant running Payment Manager to connect into Mojaloop. Currently, they're doing that to connect their core system. What if they also want to connect their ATM and point of sale network in? That's going to be that's going to be what we're trying to unlock there. And then, obvious addition to that is what if they want to also speak to Payment Manager with 222? We'll see where we can help on that as well.
Excellent.
Fabulous.
So we are kind of running close to time. So I'm now going to hand over to Adrian again to talk about what we propose.
What we propose? I was going to go straight into the video.
Target for PI 40. Okay.
No, the video is only 4 minutes. We have a couple of minutes. So yeah, as Michael was saying, we want to we want to figure out exactly how we're going to use ISO messaging. We think there's some inspiration to be had from things like open banking, but those are not ISO messages, but a lot of them use ISO compatible data models. So there's some stuff to look at there. Payment Manager, as I mentioned previously, is, we're doing some work on using that as a component that would run inside the participant admin boundary and allow them to connect their core system. We're thinking about adding support for 8583, and then a second thing there would be to add what we call a connector there for 222 as well. Then as part of the reference architecture work, we are looking at, where can we support ISO 222 natively within, Mojaloop, so that we support this idea of different message formats for the same semantic. And then finally, we would need to put a business justification together for the changes that we think are necessary to some of the ISO 222 messages to support our cases. And those could also be new messages. So if we think PISP is only going to be supported by some new messages, for example, in the authorization flows, that would be business justification as the process would follow to have those added. And then finally, working with the product council and the community to position Mojaloop as a tool for ISO 222 adoption strategies. So if somebody, as I mentioned this in the previous talk, if somebody is looking at moving to 222, hasn't done that, and is trying to understand how 222 maps onto their use cases, Mojaloop can actually be the tool they use to get there, rather than trying to adapt Mojaloop to an existing set of messages. Mojaloop can actually be the reference. So that's I think quite an exciting thing to explore from a product perspective as well. And with that, I'm going to share our submission video. So we submitted a 3-minute video, and then we're asked to submit a 4-minute video with an introduction that followed, I forget his name, Andrew, Sam will remember his name, the guy who was hosting the session in the BIS Innovation Summit. So you'll hear a thank you, Andrew, to kick it off, but that's just Leslie Ann playing her part.
Should be a thank you, Adrian.
It should be, yeah. So, and over to you, Leslie Ann.
Thank you, Andrew. It's an honor to be chosen as one of the hackathon winners. The Mojaloop Foundation is a non-profit open source foundation founded in 2020, hosts an instant payments clearing infrastructure as a digital public good supporting financial inclusion growth. Let's set the scene. 80% of the cost of cross-border payments is in the last mile delivery of money. Today, there are existing last mile payment networks to tap into. The mobile money industry sprang into life over 10 years ago, focusing on delivering efficient digital low-cost accounts to those unable to access financial services. And there is a vibrant global diaspora who regularly send money home, as well as many donor agencies who remit social payments. Our hypothesis is that fragmentation leads to high costs and delays in receiving money when things go wrong.
Our submission demonstrates how, using ISO 222 messages and the Mojaloop APIs, we're able to connect traditional market participants with the many different account holding institutions in the developing world's financial ecosystem. To do this, we map the Mojaloop 3-step transaction pattern onto ISO 222 messages and leverage the Interledger protocol to include end-to-end data elements that connect these disparate systems. The Mojaloop 3-step transaction pattern allows a debtor agent to, firstly, discover if the creditor identifier they have, such as a mobile number, identifies a valid creditor account to which they can route a payment. Secondly, agree the terms of the payment with the ultimate creditor agent. And finally, execute the payment instruction. Mojaloop systems also use the Interledger protocol, which mandates the sending of an end-to-end data element called a payment condition as part of the final instruction. The payment condition is pre-agreed between the parties. It has a cryptographic signature called a fulfillment, which is only produced by the creditor agent when the payment is cleared to the creditor. The fulfillment data element, passed end-to-end from the creditor to the debtor, can be relied upon by intermediaries and the creditor itself as a cryptographically verifiable signal that the creditor has been paid. Market infrastructure, such as the Mojaloop clearing system, consider delivery of the fulfillment as a signal of finality and an indicator that the payment may be settled.
In our demo, Amanda provides the phone number and the amount to Lake City Bank on our app and does a get quote. Lake City Bank, using a global discovery service, finds out that Equity Bank can play the role of an intermediary, provides the transaction details using a paying 001 message. Equity Bank does a lookup and a transaction agreement with RounduPay, and then relays back the details using a paying 01.
Amanda accepts the terms of the payment and proceeds. This results in a PAC 008 message being sent through Equity Bank to RounduPay, with the resulting paying 002 message being received by Amanda's bank as confirmation. One can view the activity logs and view each of the ISO messages, for example, the CAMT003 here, which can be opened up and observed.
Mojaloop uses the Interledger protocol because of the finality provided by a cryptographic signature in the payment instructions. This facilitates straight-through processing without the need for reconciliation and dispute resolution. It avoids the errors that result in delays and costs that poor users can ill afford. It offers, first, a way for the banked and the unbanked to exchange funds safely, quickly, and securely. Second, confidence that payments are being sent to the intended recipient and that the funds are being cleared to them. Third, transparency to all parties of the complete terms of the transfer. And finally, certainty for the debtor institution of the finality of creditor payment. we extend the reach of the ILP protocol into the traditional payment market infrastructure by passing the necessary interledger data elements in ISO 20022 messages so that they can be exchanged end-to-end. We further expand the use of multiple ISO 20022 messages to facilitate a complete three-step transaction, providing a traditional debtor with confidence that their payment is going to the intended recipient and trust in its finality.
This submission was prepared by a diverse group of participants in the Mojaloop open source community. To learn more about Mojaloop, please visit mojaloop.io or feel free to email me.
There you go. Thank you very much, everybody. Just in time. And I think we won because of the way Michael says ISO 20022.
One more
Simeon,
time.
all yours. ISO 20022. There you go. Or 20022. Or 20022. See you all in the next session. Yep, that's the one.
Okay.